How's everyone doing? You're back with your boy Jono for another quick math lesson. Today we're going to look at vertically opposite angles and how these can save us a huge amount of time moving forward. When we get two lines that intersect each other, we are left with four angles that are around that middle vertex or that middle point. And it just looks something like this. Because we know that a straight line's equal to 180 degrees, if we know one part of it, we can find out the other part incredibly easily just by making an algebraic equation that equals up to 180. Once we've done that, we just have to do it again. But we're going to find out a shortcut incredibly quickly in order to minimize the amount of work that we need to do. So for this example here, we've got a straight line and it's made up of x and 130. I actually want you to ignore the other parts of this angle just to start off in order to see where we're going. From this, we know that it's a straight line. 130 makes up part of it and the x makes up the rest of it. We can find out that size incredibly quickly. X plus 130 is equal to 180. If we minus 130 from both sides, we're left with x is equal to 50, and that's pretty easy. But now if I took this exact same concept, I know that I've got a 50-degree line, but now instead of using the 130 from before, I'm trying to find out that x again on another straight line. Well, this is x plus 50 is equal to 180. If I minus 50 from both sides, I get x is equal to 130, which is really suspicious because that's what I had before. So I think you could see where this pattern's going. If I asked you to work this one out, you can just kind of see by the pattern that that other side's probably going to be equal to 50 as well. And we can check this out. If we know that a revolution is 360 degrees, or all the angles around a certain point is 360, if I do 50 plus 50 plus 130 plus 130, I should get 360. And I do. So that means that everything fits in perfectly, and I think we're on the right track to seeing where this is going to go. So the big trick here is that the angles on the opposite sides of the point, right? The 130, 130 and the 50, 50, they're called vertically opposite angles. And vertically just means around the vertex. So not just up and down, right? The 50s were horizontal, but opposite on the other side of the vertex is what we're talking about. And these two numbers that are vertically opposite are always exactly the same. And that's going to help us out a lot. Because of this, we don't have to do a huge amount of working out. We don't have to find those supplementary distances every single time. We can just say, oh, these two are on the opposite side of the vertex. They must be vertically opposite, so they must be the same. So for this, if I asked you to find all the unknowns for this question, instead of doing what we did in the last example, we could just write immediately, oh, x is equal to 83 because these two things are vertically opposite. You do have to tell me why you know they're the same. You have to write vertically opposite. That's the reason for it. But we don't have to actually think about this at all. We just know, hey, these two things are across a point, so they must be the same. From here, I can find y incredibly quickly. Y has to be supplementary to those 83s. So I've got y plus 83 is equal to 180. If I minus 83 from both sides, I get the answer of y is equal to 97. If that y is 97, then that z has to be 97 as well, and we're done. Again, we can check this. If we do 83 plus 97 plus 83 plus 97, it gives us the answer of 360, and that again has to be the sum of all the angles around a point because it's just a circle. Again, all you have to do is write how you know these things. If they are vertically opposite, you'll get a mark, and this is all we need to do. These questions often freak students out because there's a lot of unknowns happening and there's a lot of stuff that they need to find out, and they're only given one number. But you're just going to see the same numbers pop up over and over again, so please back yourself when you're getting the same answers and don't freak out. I think you've got this one down pat, and I'll see you later.